Okay, so continuing on into today's topic. Today is all about naming branched hydrocarbons, naming and drawing branched hydrocarbons. So yesterday or in the last topic, whenever you did that, okay, we did unbranched hydrocarbons. So those were just often called straight chain. It means there's no branches coming off of the trunk of the tree. We were basically just doing trunks, okay? All that we're going to do today, we're not going to change any of the rules we had before. We're just going to add one more, and that rule will help us when we're naming something with branches. So we're going to get rules for naming the branches today, okay? So, hey, just like before, what did we do? What did we do when we were going to name an unbranched hydrocarbon? Well, step one was we had to figure out what it started with. To figure out what it started with, we had to find the longest continuous chain of carbon atoms in the molecule, right? No different now, okay? So I suggested that you circle it before. Now you're really going to want to circle it because there's going to be carbons that are not part of this big, long, continuous chain, okay? So we call this the parent chain. It's called the parent chain because it's the big one and the smaller ones kind of branch out off of it, kind of like you were smaller at one point and you kind of branched out away from your parents, right? So the parent chain, okay, I think of it like the trunk of the tree, right? And the trunk of a tree will have branches coming off of it, but the trunk is the big, long, continuous part, okay? What should you do next? Well, once you've circled the parent chain, it'll be really obvious what the branches are. So just the branches will stick out like a sore thumb after that, okay? Now we call each branch an alkyl group. Remember we called ones with only single bonds alkanes, and with double bonds alkenes, and with uh, triple bonds alkynes? Well, we call a branch an alkyl group, okay? Which means, remember, if say we had an alkane with two carbons, it was ethane. Well, now if we have a branch, since it's an alkyl group, we would call that ethyl, okay? If it had three, we would have called it propane. Now we're going to call it propyl, but just the branches. You'll see what I mean in a sec, okay? So we name each group with the prefix that corresponds to the number of carbons in the group, just like we did before. So if it had two carbons, we'd call it ethane. Now if the branch has two carbons, we're going to call that an ethyl branch, okay? So like it said, the ending of the group name will have the suffix "il." It'll just end in "il." The same way an alkane ended in "ane," or an alkene ended in "ene," or an alkyne ended in "ine," an alkyl group always ends in "il." Okay, then we, again, just like before, we number the carbons in the parent chain, starting at the end that will make branches be closest to parent carbon number one. So like we did with our double and triple bonds, we have to say where the branches are, which carbon they are on, okay? And just like with the double and triple bonds, we have to give it the lowest number that we can, okay? So always number your parent chain from the end that will make the branches be the lowest, okay? Just a side note on that, you might come across one that has a double or a triple bond and branches. If that's the case, how do you decide which one to prioritize? Well, we prioritize the double or triple bonds. So double or triple bonds still get the lowest number, even if it means giving the branches a higher number, okay? So that's kind of a side note for number 3. DBs, double bonds, and triple bonds still get lowest number, even if it means giving branches a higher number. So that just means if you're deciding between giving a branch the lowest number and a double or triple bond the lowest number, you should give it to the double or the triple bond, okay? So that rule never goes away. Double and triple bonds always have the lowest possible number, even when there's branches involved, okay? So quickly, let's just break down what does this mean. So 2-methylpropane, okay? What does that mean? Well, propane, we know what that means. Propane, right? That's just 3 carbons and no double or triple bonds, okay? And then 2-methyl. So this tells us that on the second carbon in this propane, there is a methyl group. Hey, how many carbons do you think are in a methyl group? Well, methane had 1 carbon, so you guessed it, a methyl group will have 1 carbon, right? An ethyl group will have 2 carbons. Okay, great. Now, if there is more than one branch of the same type, all we do is we add in a prefix to say how many. So if there's just one, we don't bother. But if there's 2, we would say di, 3, tri, 4, right? A triangle has 3, a tricycle has 3 wheels, tetra, penta, hexa, hepta, octa, okay? So that just means, for example, if you have 2 methyl branches, you would say where they are, and then you would say dimethyl. So this is here, okay? So there's an example down here. We have 2,3-dimethyl So all that means is we have butane, which is 4 carbons, no double bonds, right? And then on the second and the third carbon, there is a methyl group. The di means there's just two methyl groups overall. So dimethyl tells us somewhere on this butane there are two methyl groups. Where? 2, 3, okay, on the second and the third carbon. So this is just kind of one example. We will do many, but that's one, okay? So don't forget the rules for naming with double and triple bonds. They still apply, okay? And like I said before, the first priority is still to make sure the double bonds get the lowest numbering, even if it means giving a higher number till the branches or the alkyl groups, okay? So are we changing anything from yesterday? No, not at all, okay? All the rules are still there from yesterday, okay? You don't have to change any of the rules you have. We're adding one more layer today, and that's just how to name it if there are branches. But everything else is still there from yesterday. This isn't a new thing. We're just kind of adding a new tool. So let's practice some naming. Okay, so like yesterday, right, what should we always do, or whenever we're doing this? Find the longest continuous parent chain. Now, it can be a little trickier to find because now notice there's little branches coming off, but look, if I circle this one, 1, 2, 3, 4, 5, okay, let's just check that there's not a longer one. What if I went this way? 1, 2, 3, 4, 5. Okay, so it doesn't matter. Either way, the longest parent chain is 5 carbons. So there we go. I can already write part of the name down. 5 parents in the carbon chain. What does that tell me? Well, it tells me this thing is going to have pent. Notice I didn't say start anymore because the branches actually go at the beginning, right? So it ends based on bonds, but it begins based on branches. So this part is actually kind of in the middle now. So pent. Okay. Next thing, same as always, are there any double or triple bonds? I don't see any, right? Single bond, single bond, single bond, single bond. So single bonds only. Okay, so what does that mean it ends in? Well, ane for single bond, ene for double, ine for triple. So pent, ane. There we go. Okay. So we've covered the 5 carbons in the parent chain with our pent, right? We've covered that there's only single bonds with the ane. What are we missing? Well, we're missing the fact that there is a branch here, right? There is a branch right there. See it? See how it sticks out way more once you've circled the parent chain? It's a lot more obvious what's a branch. Okay. Now, question for you. How many carbons are there in our branch? And what kind of prefix matches with 1 carbon? Well, it's meth, right? If you check page 9, it's meth. So this is, because it's an alkyl group, this will be methylpentane. Okay? Now, what does this name so far tell us? It tells us there's 5 carbons in the parent chain, there's no double or triple bonds, only single bonds, and the methyl part tells us that there's a branch somewhere that has 1 carbon. Okay? Now you're saying to yourself, well, where is that branch? Good question, right? That's the last thing we're missing here. We know that there's a branch with 1 carbon, we just don't know where it is. Now, we have 2 options here, like before. So I'll give you 2 options. We can go 1, 2, 3, 4, 5 when we number our parent chain, or we can go 1, 2, 3, 4, 5 when we number our parent chain. Which one should we do? Well, we should give the branch the lowest number possible, right? There's no double or triple bonds to worry about here that we have to give priority to. So we'll give the branch the lowest priority, and we'll say it's 2-methylpentane. So we will not number it this way, right? We won't number it this way because then it would be 4-methylpentane. So not that way, that way. Okay, let's do this one. So find the longest continuous branch. Now this is where they can trick you a bit, right? Because you might be tempted to just say, okay, there we go, big long straight chain, that's the longest branch. But be careful. I actually see a longer branch here. Do you see it? Okay, there is a longer continuous thing where there's no breaks. Look, 1, 2, 3, 4, 5, 6, 7, 8 versus 1, 2, 3, 4, 5, 6, 7, right? So this is actually the longest continuous branch. Okay, kind of tricky. And this one is just a branch. So in our longest chain, what do we have? We have, again, 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this thing is going to have oct, right? How is it going to end? Well, to figure out how it's going to end, we need to see if there's any double or triple bonds. Do you see any? I don't, right? Once again, single bonds only. Single bonds only. Okay, so what's it going to end with? Well, ane for single, right? So octane. Ane for single, ene for double, ine for triple. Okay. So we've covered the oct. We've covered that there's 8 carbons. We've covered that there's no double or triple bonds. What are we missing? What haven't we told whoever's reading this about this thing yet? We haven't told them about the branch. So I see a branch right there. Okay, how many carbons are in the branch? Again, just one, right? So this would be, what would be the prefix that matches? One, it's methyl, once again, okay? So now what have we said? We said there's a branch with one carbon somewhere on this parent chain that has 8 carbons and contains no double or triple bonds. What's missing? Well, we said there's a single carbon somewhere, and you say, well, where is it, right? So it's either on carbon number, if we go this way, it's on carbon number 1, 2, 3, 4, 5, 6, 7, 8, or it could be on carbon. If we go the other way, it would be on carbon number 1, 2, 3, 4, 5, 6, right? What should we do? We should give it the lowest possible number. So we're not going to do that way. We're going to do the first way I said, right? We'll put it on carbon number 3, and this will be 3-methyl octane. Okay, let's do this one. So longest continuous chain of carbons. So we need to find the longest straight chain of continuous carbon. So just always try a few ways to make sure. So 1, 2, 3, 4, 5, 6, 7. That's an option. What about 1, 2, 3, 4, 5, 6, 7? Okay, doesn't matter. Those are tied. 1, 2, 3, 4, 5, 6. Nope, that's smaller. Okay, let's just go with that one. That's probably the easiest. Jumps out right away anyway. Okay, so first things first, what does this tell us? It tells us 1, 2, 3, 4, 5, 6, 7. So we need to say the prefix for 7 carbons. That's hept. Okay, there we go, hept. Now we're going to build the rest of the name. So next, always next, is are there any double or triple bonds anywhere there? Nope, all single, 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 single. So single bonds only. Okay, so that means it's going to end in ane once again, heptane. Okay, next, what are we missing? We've told them about the 7 carbon parent chain. We've told them about the single bonds only, but we have not mentioned these guys yet. Okay, so now we have 2 branches. Are the branches the same type? Yes, they both only contain 1 carbon, right? So these are 2 methyl groups, okay? Be careful, don't call this ethyl because it's not 2 carbons on 1 branch. It's 2 branches with 1 carbon. So it's not 1 ethyl, be careful, that's a common mistake is to call this ethyl. This is 2 methyls, so we would say it is dimethyl. So what that tells us is somewhere on this heptane, there are 2 methyl groups. That's what the di means, okay? So dimethyl as in 2 methyl groups, okay? Now what's missing? Well, where are those methyl groups? Okay, so we can either do 1, 2, 3, 4, 5, 6, 7. We could do it that way and have 2, 5-dimethyl, or we could do it the other way. If we do it the other way, we would have 3, 6-dimethyl. So our options are 2, 5, or 3 and 6. Well, we should give it the lowest possible, right? So we're not going to do that one because 3 and 6 is higher than 2 and 5. So we should do that one, okay? So what is this? This is 2,5-dimethyl heptane. Okay, now here's the first one where we have to do both the branches and a double or triple bond. So we're going to have to work both of those into the naming. Okay, don't worry. We just follow all the rules we always have. Okay, we're just going to follow them all at once. Now, I'll be honest, this one here is tricky. This is a tough one, okay? This is probably the hardest type you would ever encounter because there's a bit of a trick here. So remember we said the parent chain is the longest continuous chain of carbons. That is true, but there's a little bit more to that. It's the longest continuous chain of carbons that still contains any double or triple bonds, okay? So what you might be seeing is this and going 1, 2, 3, 4, 5, 6, and you'd be right usually, but notice that that doesn't contain the double bond. So to get the parent chain, this is actually the parent chain. Even though this would be a longer one, it doesn't contain the double bond, so it can't be the parent chain. So I'm just going to add that note here. Okay, so I've just added that note there that the parent chain is the longest continuous carbon-carbon chain. Usually that's all you'll need to remember, but on a tricky one like this, okay, it still needs to contain any double or triple bonds. So this is actually our parent chain, even though this one is longer because this one wouldn't contain our double bond, okay? That's probably the toughest these would get. Okay, we've got our parent chain circled. Right away, we can start to write down some information here, okay? So how many carbons? 1, 2, 3, 4, 5. So what's the prefix that matches? Pent. Okay. All right, how is this going to end? Well, what tells us the ending? The ending is based on whether there's any only single or if there's a double or a triple bond, right? Well, do you see any double or triple bonds? I do, right? That's why we had to make the parent chain kind of weird this time. That is a double bond. Okay, so what does that tell us? It tells us it's going to end in not ane, but ene. Okay, so pentene, what does that tell you? It tells you there's 5 carbons and somewhere in there is a double bond. So what do you ask me when I say that? You would say, well, where is that double bond, right? So let's figure it out. Remember, we have to give the doubles or triple bonds the lowest number possible. So should we start down here at this end and call this carbon number 1? Or should we start down here at this end and call that carbon number 1? Right, we should start down here because then we can make it pent 1-ene. It doesn't get any lower than 1, right? Okay, perfect. All right, so there we go. We've covered that there are 5 carbons in the parent chain. We've covered that there's a double bond on the first carbon. What's missing? Well, look at these branches that we haven't said anything about yet, right? So on the second carbon, 1, 2, we numbered them like that to give our double bond the lowest number possible. Okay, so now they're stuck numbered that way. On the second carbon, we have a branch with 2 carbons in the branch. So what prefix matches with 2 carbons? If you check page 9, you'll see that it is ethyl. Okay, so we have ethyl pent 1-ene. So where is the ethyl? Well, we just said on the second carbon, right? So we have 2 ethyl pent 1-ene. All right, what have we communicated? We've communicated 5 carbons. We've communicated the double bond and where it is. We've communicated this branch and where it is. We're still missing this branch. That's okay. What kind of branch is it? Well, it's got 1 carbon, right? So it is a methyl group, and it's on the 4th carbon in the parent chain. So we would say, first, not get ahead of ourselves, methyl, okay? And where is it? It's on the 4th carbon in the parent chain, okay? So like I said before, right, the number tells you about what's coming next, where that is. So 4th carbon has a methyl. 2nd carbon has a ethyl. The 1st carbon contains the double bond, the ene. Okay, so the number tells you where the thing that's coming next is. So 4-methyl, 2-ethyl, pent 1-ene. Really rolls off the tongue, right? Okay, let's look at this one. Parent chain is the longest continuous carbon-carbon chain that contains any double or triple bonds. Okay, so this one, right? I see there. Okay, it contains the double bond. It also is the longest this time. So 1, 2, 3, 4, 5. Okay, what matches 5? Which prefix? Well, pent, right? Pent means 5. Pentagon has 5 sides. So pent, okay. Next is the ending. How's this thing going to end? Well, does it have any double or triple bonds? Yep, right? Double bond right there. So what's the ending for a double bond? It's ene. So far we've said it has 5 carbons and we've said that it has a double bond somewhere. What's left? Where is that double bond? So 1, 2, 3, 4, 5, right? Or should I number it the other way? What do you think? Well, if I number it the other way, the double bond is going to be on carbon number 4, right? 1, 2, 3, 4, 5. So I should stick with this way because now the double bond is on the 1st carbon, pent 1-ene. All right, great. So I've covered the double bond, I've covered the 5 carbons. What's missing? What have I not told the reader about yet? I haven't mentioned these branches, okay? So those branches, are they the same type of branch? Yep, right? They're 2 methyl groups. So they are 2 different methyl groups. So this is not ethyl, this is dimethyl, which just means 2 methyls, right? It's kind of like having a $20 bill and 2 $10 bills. Yes, both have $20 in the end, okay, but they are 2 different things. Same thing here. 2 methyls and 1 ethyl will both have 2 carbons, but that doesn't mean they're the same thing, okay? So we have dimethyl. What's left? We have to say where they are, but we have 2. So how do we say where they are? We use numbers and commas. So they are on carbon number 2 and carbon number 3. 2, 3, dimethyl pent 1-ene. By the way, folks, once you've numbered your parent chain, you can't switch it up. So you number it for the double or triple bond, or you number it for the branches, but you got to stick with one. You can't go back and forth. Now, here's another one, tricky. You want to know a very common student mistake would be to see this and say, aha, there's my parent chain. It's nice and flat. But be careful, I see a longer one. Do you see it? So that one has 1, 2, 3, 4, 5 carbons. I see one that has 1, 2, 3, 4, 5, 6 carbons. Okay, so always be careful. Look for the longest parent chain. They might try to trick you with some twists and turns. Okay, so we've got 1, 2, 3, 4, 5, 6. So what goes with that? Well, how many sides does a hexagon have? 6, right? So hex is going to be our kind of middle here. How should it end? Well, does it have any double or triples? Yep, that's a double bond. Okay, so this thing is going to end with ene, hexene. All right, we have to say where that double bond is, right? So we could say it's on carbon number 1, 2, 3, or we could say it's on carbon number 1, 2, 3. Okay, so those don't matter, but look, there is kind of a tiebreaker here. If I go this way, 1, 2, 3, 4, and this is a bit of planning ahead, right? Well, yes, my double bond will be on 3, which won't matter. It'll be the same as if I go this way. But then look, this branch that we're eventually going to have to number would then be on the 4th carbon. What if I go the other way? What if I start here and say, okay, this is carbon number 1, number 2, number 3, 4, 5, 6. Okay, what if I go that way instead? Now look, now my double bond is on carbon number 3. And so is the branch. So it's 3, 3 versus before when it was 3 and 4, right? So since that's going to give me the lower number for the double bond and for the branch, I should go that way. So that should be my numbering, okay? So this is going to be, the double bond is on the 3rd carbon, so hex 3-ene, okay? And all that's left to do is tell people where the branch is. So on the 3rd carbon, 1, 2, 3, there is a branch. Okay, and what kind of branch is that? How many carbons are in that branch? Count them up. I only count 1, right? So that is a methyl group. We have methyl hex 3-ene. So this, so far, what does this say? It says we have 6 carbons. Okay, the 3rd one has a double bond, and somewhere in there is a branch with 1 carbon, right? And so you would say, well, where is that branch? And we would say, oh, right, it is on the 3rd carbon in the parent chain. So 3-methyl hex 3-ene is the whole name. All right, drawing, like I said, drawing is always easier because they can't trick you, right? You get to draw it. You probably won't trick yourself. Okay, 2-methyl pentanes. Let's break this down. Pent tells us the number of carbons. Ane tells us about double and triple bonds. Okay, now methyl is going to tell us about branches, and the 2 tells us where the methyl is. Okay, so let's start with pent, like we always do. So I'm just going to put down my 5 carbons, single bond them for now, and if there are double or triple bonds, we can worry about those later. So 1, 2, 3, 4, 5. Okay, so there, that's dealt with, right? We already dealt with pent. Okay, ane. That means, do we have to add any double or triples? No, because ane just means all single bonds, right? So 1, 2, 3, 4, 5, we're good on pent and we're good on ane. That wasn't so bad. What's left? We just have to say that there is a methyl group on the 2nd carbon. So let's make this the 2nd carbon, and we will say there is a methyl group, which means a carbon, which means a branch with just 1 carbon, right? So there we go. Now, have we covered the 2-methyl? Yeah, we have, right? We've actually covered everything now. So what's left to do? Just like before, fill in everything with hydrogens until all the carbons are happy, okay? So this is making 1 bond, so it needs 1, 2, 3 more with hydrogen. This guy here is making 1 bond, okay? So it must make 3 more, okay? This one is already making 3, so to make 4, it only needs 1 more. This one is making 2, so to make 4, it needs 1 more, 2 more. Okay, same for this one. And this one is making 1, so it needs 3 more. There we go, 2-methylpentane. So it's just about breaking the name down, right? Building it up from the basics. So start with the pent, then do any double or triples, then add any branches. Let's do the next one, 3-methyl-hex-2-ene. Okay, so start with this part. That tells you how many carbons. Hex means 6, right? 1, 2, 3, 4, 5, 6. Okay, done. We've already dealt with the hex part. Next is 2-ene. So ene tells us there's a double bond. 2 tells us where it is, right? So there's a double bond. Where is it? It's on the 2nd carbon. So 1st carbon, 2nd carbon, double bond. Okay, there we go. We've dealt with 2 and ene. What's next? methyl, and 3-methyl. Okay, so that means on the third carbon, there is a methyl group. So 1, 2, 3, what's a methyl group? Well, it has 1 carbon. Okay, we've dealt with the 3 and the methyl. Have we dealt with everything that's in the name? Yes, that means we've dealt with everything kind of interesting, everything that has to do with the carbon and the actual structure. All that's left to do now is fill in the hydrogens. Okay, so for this one, for a methyl group, I'm just going to show you. Usually we just do that because it's always going to be like that for a methyl group, right? Just so it doesn't get as crowded as up here. There's nothing wrong with doing what I did up here, but just wanted to show you this because that's definitely the more common way of doing it. Okay, fill it in until every carbon's made 4 bonds. 3 for you. This one's got 1, 2, 3 already, so it only needs 1 hydrogen. This one's got 3 already too, so it only needs 1 hydrogen as well. 2 here, 2 here, and 3 here. There we go. We drew 3-methylhextuene. Okay, let's do 2,2,3 trimethylheptane. So break it down. Start with the hept. So hept means 7 carbons. So 1, 2, 3, 4, 5, 6, 7. Okay, there we go. Hept, already done. Right? Okay, ane. Ane means no double or triple bonds, single bonds only. So, boom, that was easy. Done. No double or triples. Okay, looks scary at first, but think about what it's saying. 2,2,3 trimethyl. So that means there's 3 methyl groups, right? A tricycle has 3 wheels. There's 3 methyl groups. And you say, okay, great, there's 3 methyl groups, but where are they? Oh, they're on the second, and the third. Okay, so that looks weird at first, but all that means is there are 2 of the 3 methyl groups. 2 of them are on number 2, and 1 of them's on number 3. So let's just draw those in. So on the second carbon, we have 2, 2, 3. Now I'm going to show you a very common mistake. Okay, so this is wrong. People see 2, 2, 3 and they go C, C. Oh, look, there's 2 methyls on the carbon. Is this really 2 methyls though? No, right? This is 1 ethyl. So remember, 2 methyls is not the same thing as 1 ethyl. 2 $10 bills and 1 $20 bill, they might both add up to 20 bucks, right? But it's not the exact same thing. Same thing here, right? 2 methyls and 1 ethyl might add up to 2 carbons, but it's not the same thing still. Okay, so what does two methyls look like on the same carbon? Well, we would put 1 methyl down there and we would put 1 methyl up there, right? See how that's 2 different methyl branches now? Okay, so that's the 2 methyl part. What about the 3? Well, there's just another one. Notice how there's 3 methyl groups, so trimethyl. And where are they? They're on 2, 2, and 3. All right, so we've dealt with the 2, 2, 3 trimethyl. Have we dealt with everything interesting? So what's left to do? Fill in the hydrogens. Notice this one doesn't get any because it already used all 4 bonds. Okay, last example, 3-ethyl 5-methyl octane. So 3-ethyl 5-methyl octane. So let's start with the oct, right? Because that tells us how many carbons in our parent chain, which is like the base that we use to build up off of, right? So oct, how many legs does an octopus have? 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's oct, already dealt with. Okay, ane. Ane means single bonds only. So that was easy. That's already dealt with. Okay, what's left? 3-ethyl 5-methyl. So let's do the methyl first. Okay, on the 5th carbon, there is going to be a methyl group. 1, 2, 3, 4, 5. So a methyl group, meth means 1. So this branch is going to have 1 carbon, CH3. Okay, 3-ethyl, that means on the 3rd one, we're going to have a branch that contains 2 carbons. So what does that look like? Well, 1, 2. Okay, and usually we would say C. We could go H, H, but the more common thing to do again with these branches is to just kind of simplify it down and just go CH2. Okay, and then instead of going the H, we would just go CH3. Nothing wrong with doing it the other way. This is just a little bit quicker and neater. Okay, there we go. We dealt with the 3-ethyl 5-methyl. So we've dealt with everything interesting. That means what's left? Fill in the hydrogens until every carbon's happy. Okay, so this carbon's got 1, 2, 3, 4, 3, 4, 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and so that wraps up topic 2, naming and drawing branched hydrocarbons. Now again, I'm going to kind of end the teaching part of the video there, okay? So you can now try more of the practice work. I'll post again which questions you should go for right now, okay, if you're looking to really solidify that. However, I'm again going to make kind of another, if you're not feeling great about this yet, you want to see a few more examples, I'm going to go through these whiteboard practice ones. I do suggest, though, try pausing the video, try doing these, or opening up the extra examples video and just taking a look, okay? Just because, again, right, it's like riding a bike. You can watch me do it all you want, but you got to try it yourself before you actually know how to do it. So I will, in another video, do extra examples, do these extra examples that would normally be whiteboard practice, but I get if you want to see it a bit more before you jump in on your own.